Okay, so hopefully you've watched the naming, you've watched the reaction types, the balancing, the redox equations, the acid-base neutralizations. We're going to move on into stoichiometry, and you need to make sure you know how to both name and how to write in reactions before you do that. So the first thing is we have at the very bottom of the page before, we have 3 definitions of a mole. Remember, a mole is an amount of a substance that we have determined is equal to these values. So a mole is equal to 22.4 liters of gas at STP. So if I told you H2, that hydrogen gas at standard temperature and pressure, remember that is 0 Celsius and 1 atm. A liter, so a mole of hydrogen gas would take up 22.4 liters of space. Right. The next definition, Avogadro's number. I can't spell Dro's number. 1 mole is equal to 6.022 times 10 to the 23rd molecules. A lot of molecules. A mole of hydrogen gas that contained 22.4 liters of gas would also contain 6.022 times 10 to the 23rd molecules. And finally, a mole is equal to the molar mass of any given atom or element or molecule. So molar mass for carbon dioxide would be 16 plus 16, that's 32 plus 12, be 44 grams per mole for carbon dioxide. For, let's just do, I don't know, calcium. Calcium all by itself, that would be about, I think is about 40 grams per mole. Right, and you get this from the periodic table where you're looking up the masses of the different things and you're adding up. So 1 carbon, 2 oxygens, and now calcium is all by himself. Okay, so that is all the beginning step that you need for stoichiometry. So I'm going to start with the basic stoichiometry stuff now, and in the next video I'll do the more detailed stuff. For the first bit, it's converting between these 3 definitions, from grams of CO2 into moles. Let's grab a blank sheet of paper, and let's go straight from grams of CO2 into moles. Of course, I keep losing my blank sheets of paper when I'm doing this, but that's okay. We'll do this. Grams of CO2, and I said 54.2 grams CO2 equals how many moles? So there's a lot of different ways you can do that. That I think we'll go back to this table method. So let's put our given here. Now normally the next step would be put our balanced reaction coefficients in here, but we're not actually going to have to do that side because we're only talking about one thing. So if we have 54.2 grams of CO2, underneath that we could say, well, what is the molar mass of CO2? And we could just say, we already did that, right? Carbon is 12, plus there's 2 oxygens, that's 16. So the total of that is 44 grams per mole. So if we just come over here and put 44 grams per mole for CO2, we don't actually need this space for now. And so you could grab your calculator, which I of course have moved, and I'm going to go 54.2 divided by 44 gives me 1.23 moles CO2. Okay. The next question says, let's convert 3.2 moles of H2 gas into liters. So if we have 3.2 moles H2 gas into, sorry, into liters. We can do the same thing. 3.2 moles times so H2. So we don't need to do anything. He's already in moles, right? Our given is already in moles. So now we need to come over here and say, well, 22.4 liters per mole for anything. So now 3.2 times 22.4, 71.68 liters. Okay. The next one, actually, before we go any further, 71.68, and that should be rounded, right? This is only 2 sig figs, so let's make that 72 liters. Let's go back to the other one. I said that one was 1.23. 1.23 moles, and that's okay because that's 3 sig figs, and so is our given. Don't forget your sig figs, especially in type-in answers on the SWL. 0.81 grams of calcium into, moles of calcium. Oops, moles calcium into grams. All right, so I guess calcium's was 40, and I was right, so it's 40. But we're not going to put it here because we're already in moles. So we only put something here if we're not in moles. We're going to actually put that 40 grams per mole over here for calcium. So we put, only time we put something here is if we are not starting with moles. So 0.81 times 40, I am dealing with 3.32.4 grams. So if I look, I only have 2 sig figs, that's 3, so I'm probably going to go ahead and just say 32 grams. Last one before we take another break, and I'll come back and do the more complex problems. So the next one is 5.16 times 10 to the 23rd molecules into moles. And notice I don't even tell you what kind of molecules that is, but it doesn't really matter. So this is not in moles, so I'm going to stick a number here to convert molecules to moles, and I'm going to put Avogadro's number. So molecules per mole, molecules per mole. All right, and I'm lazy, so I know times 10 to the 23 on the top times 10 to the 23 on the bottom. I can cross those out. So 5.16 divided by 6.022. And I get, I don't really need those guys this time, I get 0.85685. Way too many sig figs. Let's go back to our original question. And it said 5.16. So we're going to go ahead and give 3 sig figs, 0.857 mole. So go back through these, try to do a couple of the 2 steps on your own, and then I will talk to you in the next video.